Okay, this next example, we want to fill in the missing sides. This is our special 30, 60, 90 triangle. So we know opposite of 30 degrees is 1. Our hypotenuse side is 2. And this is square root of 3. So we want to know the sine of 30 degrees. So we go find the angle that's 30 degrees. Theta is 30. And we want to do sine, which is opposite over hypotenuse. These may be hard to read, but opposite over hypotenuse. So opposite of 30 is 1. Hypotenuse is 2. So the sine of 30 is going to be 1/2. It's going to get kind of squished up in here. All right, so now let's look at the cosine of 30 degrees. So angle 30. And the cosine is defined by adjacent, which is square root of 3, over the hypotenuse, which is 2. So square root of 3 over 2. And squeeze tangent down here a little bit, so I ran out of room. So tangent of 30 degrees. So from here is going to be your opposite over adjacent. So opposite over adjacent, which is going to be 1 over square root of 3, and we want to rationalize this, so take a minute to rationalize. So you just get square root of 3 over 3. This is for tangent. Okay, now we're not doing the cosecant, secant, cotangent this time. I said let's do the sine of 60 degrees. So we're looking at this angle, which is 60, and we want to do opposite over hypotenuse. So opposite over hypotenuse. So sine of 60, and let me do it in a different color, is going to be square root of 3 over 2. Okay, now let's do cosine of 60 degrees. So we go to our angle when it's 60 degrees, and our definition is adjacent over hypotenuse. So adjacent over hypotenuse is going to be 1/2. Tangent of 60 is going to be your opposite over adjacent from angle of 60 degrees. So that's going to be square root of 3 over 2. So opposite over adjacent, square root of 3 over 2 over 1. Opposite over adjacent. Sorry about that. So we get square root of 3. Okay, we're leaving that idea for a minute and we'll go back to it. But cofunction identities are going to be, and we want to recall that 90 degrees is also the same as what? Pi is equal to pi over 2 in radians, and this is actually going to be equal. So we want to keep that in mind because we can apply the same thing but use them radians as well. So we're going to use it as degrees and radians. So it's saying the sine of theta can be used, can use a cofunction identities, cosine of 90 minus theta, tangent and cotangent, and then we have secant with cosecant. And we'll look at that in just a minute. So another way we can calculate sine of 72 degrees using a cofunction, the identities above, we can say cosine of, so for sine of theta, it's going to be this top one, is equal to the cosine of 90 degrees minus theta. And that's using this first definition right here. So now let's plug in our values. Well, we know what angle theta is. What's angle theta? Good, 72. So then that would give me the cosine of 18 degrees. So these are cofunctions. Okay, let's look at the same thing with a radian measure here. So that would be this value. So I could rewrite that as secant of pi over 2, because pi over 2 is our representation for a radian measure, and since we started in radian measure, we're going to calculate in radians, minus pi over 3 is equal to the secant. I'm going to go ahead and show this step of a common denominator between the two fractions. So it's going to be the same as secant of pi over 6. And a note you want to make here is cofunctions if the angles are complementary, meaning complementary means that they're going to add to 90. So we can see that sine of 72 and then cosine of 18. Well, 72 plus 18 equals 90. Same thing here with radian measure. Pi over 3 plus pi over 6, when you add those, would add to the radian measure of 90 degrees as well. So we can see that those are complements. Now let's flip back to the previous page. We can see that the sine of 30 and the cosine of 60, so let me draw an arrow, like these two right here are complements of one another, right? Because the sine of 30, cosine of 60, what's 30 plus 60? 90. We can see that when you evaluate those trig functions at cofunctions, what about their solutions? The same, right? And then cosine and sine, these two right here, cosine of 30 and the sine of 60 are going to be equivalent as well, and we can see that over here. Okay, so that's another example that you can see is the previous one. Okay, and then an extra one is just if you have sine of 10 and then the cosine of 80, these would be cofunctions. Cofunction identity, using cofunction identity. All right, so in 7, let's find the measure of each side of the triangle. Okay, so let's talk about some things. First of all, the very first time I did this, I had 2 sides given to me and I found a third side using Pythagorean theorem, and that was okay. The next time, I was given special triangles, my 45, 45, 90 triangle, and I was given my 30, 60, 90 triangle. So those were all things we already knew previous information about. This time, not so much. Okay, I'm only given side B. I have a missing side A and a missing side C. And all I have in my toolbox are my trig definitions that we've learned so far. So sine, let's just say the 3 basic ones. Let's look through sine, cosine, and tangent first of all. If here's my angle is 37 degrees, angle theta, which trig function, let's consider sine, cosine, and tangent, would possibly give me a known value and an unknown value so that I can try to solve this? Okay, so when I jot these down, these definitions down, I consider 37 degrees. What's opposite over hypotenuse? Opposite over hypotenuse is 2 unknown values. That will not help me. Let's check cosine. Adjacent, that's good, over hypotenuse, so I can use that one. Or I can use the tangent, which is opposite over adjacent. So I can use either of the other two. I'm just going to start with tangent. Okay, I'm eventually going to use both, so it doesn't matter which one I start with. So let's use tangent. Tangent of my angle, this time I know my angle is 37 from right here. Tangent of 37 is going to be what? Side A, opposite, over adjacent. Now, we need to solve this for the missing side, so what are we looking for? A, so we can cross multiply right here. And if it helps you to put that over 1, then we can, that would give us A is equal to 250 times tangent of 37 degrees. Okay, we'll put that in our calculator, make sure it's in degree mode, and A is approximately 188.39 centimeters. Okay, so now I just plug this information over here. I want to find side C, so I want to use, let me check adjacent over hypotenuse. So adjacent would be the 250 over hypotenuse. That would allow me to use these two. So now I'll calculate that. So I'm going to do cosine of 37 degrees. Cosine is adjacent over hypotenuse, so adjacent is 250 over the hypotenuse is C. like I said a minute ago, it didn't matter which one I started with. If I started with this one or I started with this one, eventually you're going to do both of them. Okay, cross multiply right here and solve. So we have C times the cosine of 37 degrees is equal to 250. Solve for C, so we want to divide both sides by the cosine of 37 degrees. Put that in your calculator, and we should get C is approximately 313.03 centimeters.